Well, maybe people will be joining pretty soon. I will take these minutes or these few minutes just to introduce that we are doing this workshop graduate seminar um, among researchers that are related with this International Sustainable Development Goals Network that was called by the National Research Foundation and the Research and Innovation Support and Advancement. There are three local funding agencies located in Chile, ANID, located in Norway, the Research Council of Norway, and located in Turkey, TÜBİTAK. And the universities related in here working with in this project are the Universidad Católica del Norte, the Norwegian University of Life Science, and the Bursa Uludag University. All of three universities are focusing in put together the knowledge that will allow us to advance and to have a more sustainable aquaculture and also agriculture as well. We are working with the two sides. The leaders in each country for the researcher teams is Dr. Margaret Overland from Norway, Dr. Nsi Kamil from Turkey, and who is speaking here right now for you. This is our second webinar. The first one was given by our partner from Norway. And today we are going to have two talks, one from Dr. Kamil, that is related with evaluation of sustainability in recirculation aquaculture systems. And the second one will be by Dr. Güray Çelik, related with aquaculture and sustainable development, ending hunger through responsible food production. Both talks supposed to be about 45 minutes. Then it will be 15 minutes for talking or question and answer, and then we continue. And we are preparing another, and the last one for this year, seminar that will be on December 17. That will be given from researchers belong to Universidad Católica del Norte. There will be four talks. So just keep in mind that I will be sending the link for that for you to join on time. Well, that will be, and right now I'm going to leave sharing this introduction. I will welcome Dr. Kamil to start our seminar today. And of course, I will let yourself to introduce to our public.
Okay, I'm going to share my presentation. Is it okay?
Say again?
Okay, I'm going to share my presentation.
Oh, perfect. Yeah.
Okay. Okay, can you see now?
Not yet. Right now we see your PowerPoint.
Okay. And I can change. Okay. Okay, the changing page is okay?
Yeah, when we are not seeing the slide, I mean, we're seeing the whole PowerPoint, we hold your slide, not the presentation itself, right now, yeah.
Yeah, okay. Yeah. I would like to begin in Spanish. By the way, I think just two persons from the Chile now. I want to begin with the Hola Germán, les envío mis saludos desde Turquía a todos los participantes en Chile.
Oh, thank you.
Okay. And
Muy buen español.
Yeah. Thank you. And our presentation about the evaluation of sustainability in recirculating aquaculture systems. Okay, I'm beginning now, Herman. Okay. Okay. And three different countries from the South America, from the Europe, and from the between the Euro and Asia. Eurasia, we say, the Turkey. And we want to begin with the introduction of myself. I'm an environmental engineer. I am working on some research studies about environmental technologies, sustainability, circular economy, and related issues. Okay, here is the Chile, I think so. Very important road from the Chile, Paso de los Caracoles. And I'm going to begin with a global overview and then a concept of sustainability, introduction to RAS systems, environmental evaluation, economic and social dimensions, comparative evaluation and future outlook, recent articles, and conclusion and question and answer session at the end of the approximately 45 minutes. Yes. As you know, we have some problems with the number of the population, the number of the people on Earth, and annual growth rate of the world population. Day by day, we need more food, and we have to search different resources to get enough food for the growing population. And we need daily calories per capita. If we compare with the United States and Nigeria, changing calories, as you can see on the right, share of households spending on food at home, and on the left, the blue one is daily calories per capita. And if we compare this, approximately between 2,500 to 4,000 daily calories we need as a person, even as a woman or a man. And many people around the world cannot access the food they need due to income inequality and conflicts. There are so many different problems on the world, and you can see different pictures at the bottom of the slide. And one of the approach is...
By the way, we cannot see your slide changing.
Okay, sorry. I'm going to stop sharing. Sorry. Can you see now?
Yes.
Okay, I'm going to do like this. Okay. This is the calories and sorry. Yeah. And conflicts and income inequality I mentioned. And we have we want to solve this problem with the fisheries and aquaculture. And we would like to talk about the fisheries and aquaculture. The global fisheries and aquaculture production reached 223.2 million tons in 2022. And global per capita consumption aquatic foods increased from 9.1 to 20.7. By the way, these ratios changing based on the different countries, different continents. For the first time, aquaculture surpassed capture fisheries. And we have to think about the engineered facilities and natural areas. We have to compare this. Because of these numbers, we have to think about the more feasible engineered facilities to natural resources. In 2021, aquatic foods contributed at least 20% of animal protein for 2.1 billion people. And also, aquatic foods provide 15% of animal protein and 6% of total protein worldwide. And aquatic food consumption is key to addressing food security and nutrition globally. Okay, in this project, basically, we are going to reach a sustainable food resource. The main idea, sustainability of the achieving enough food using aquaculture system, aquaponic systems. Okay, sorry. Okay, world fisheries and aquaculture trends. You can see on the graph, aquaculture production worldwide has been increasing since 1990s. These numbers is very important based on the FAO 2024. And world fisheries and aquaculture trend, total consumption of fisheries based on human consumption on the light blue. You can see the total global consumption of fishery product has been increasing since the 1990s, as I said, and non-food uses. Also, we use the fisheries not for the just human consumptions, but also non-food uses. It's approximately in a stable ratio. And freshwater and marine aquaculture production in Turkey between 2014 to 2023, and increasing day by day, year by year. And as you can see on the graph, the inland fisheries has more growth ratios based on the numbers. And aquaculture production quantities by species in Turkey: sea bass, rainbow trout, gill-tailed sea bream, and rainbow trout in marine and freshwater. We say the marine, the Turkish salmon, Orcahynchus mycis, sorry for the Latin pronunciation, but we have a special species about the rainbow trout. And the fish species with the highest aquaculture production in Turkey, the sea bass, gill-tailed sea bream, and trout. And we generally prefer based on the kitchen behaviors or general food applications. Introduction to recirculating aquaculture systems, like the environmental engineering applications in aquaculture systems, the recirculating systems is very important because based on these systems, we have to think about the more efficient production in aquaculture systems. And on the other hand, we are talking about the carbon footprint, the energy consumption, and total production ratios. Okay, the recirculating aquaculture system is a modern fish farming method in which fish are raised at high densities in a closed, controlled environments, like pools, like spatial areas, under the roof, and we can manage based on the specific parameters, based on the even in using artificial intelligence now. We have so many different automation systems to use and to grow the fisheries and other production. And let's have a look at the history of the aquaculture system. Firstly, it's written in some literature, the Japanese says, but I know this, some of the different countries applied the RAS systems. By the way, the Japanese more forward than the other countries. And origins of modern RAS traced back to the German program and mid-1970s in Denmark, and also Netherlands in 1980s. And China pioneered the development of marine RAS systems. And now different nations, especially Norway, Chile, and other countries, even in Turkey, interested in the recirculating aquaculture system and to get more fishery and other products. Okay, now we have some numbers with the market. The leading countries, Norway, Denmark, USA, the market size in the global, the RAS systems, approximately 2 billion in 2023, and expected 10% growth in this market, approximately 10% annually through the 2030. The production capacity between 1,000 and 5,000 tons of fish per year and more than 10,000 tons annually with the different products. And sustainability and trend, let's have a look. The sustainable food production, lower water use, reduced carbon footprint, and proximity to urban markets. The basic approach to apply RAS systems. Why do we need RAS systems? Maybe we can explain with these parameters. Okay, also we have some RAS systems in Turkey, in Turkey. Okay, at the 2021, 2,239 licensed aquaculture fish facilities we have. But the recirculating aquaculture systems, really low ratios we have, just 0.4%. And increasing day by day, okay, we have a facility in Muğla, Milas, in the Aegean side, next to Greece. And besides commercial use, some of the universities and educational facilities, also research and development factories interested in the RAS system in Turkey. And just for natural fisheries, by the way, they are interested in the shrimp, especially in Bursa. Okay, I would like to repeat again why RAS systems. Innovative and sustainable approach, we can achieve more effective production system using RAS systems. And we can search many different parameters within these systems. These are engineered, automated systems, and we can control many different parameters in this systems. Another one is the environmental advantages. As I said earlier, the carbon footprint reduction and energy and lower water use for the recirculating. And in general approach, the economic and operational efficiency. Other one is integration of advanced treatment technologies, because if you want to recycle your water and if you want to use the other residues originating from the plant, you can use in a different plant growth. And the last one is continuous technological development. Okay, this is a systematic system diagram of recirculating aquaculture systems. Fish tank, screen filter, particle removal techniques, and nitrifying biofilters, the gather unit, UV disinfection, and we can add many different units for the recycling of the water based on our requirements, based on the requirements of the systems. The main components of RAS is fish tank, feeding unit, mechanical filtration unit, biological filtration unit, the gather, pump, disinfection unit, aeration unit, and monitoring systems. Okay, as you can see, it's like a factory. It's called a kind of factory because we want to control every type of unit in our systems, especially the parameters of water, pH, temperature, alkalinity, electrical conductivity, and the residues coming from the fisheries and recycling ratios in the systems. Okay, another view from the RAS systems. Water consumption and reuse of RAS, zero water concept. Okay, we say zero approach is a kind of nirvana of the systems. If you want to achieve really high level efficiency, we say the zero water concept. Is it possible in technologically? No. By the way, we can reduce the total water consumption in the systems, and the main idea achieve the zero water concept in this approach. This is the feeding systems for the feed, the fisheries. These are the fish tanks. These are controlled like the oxidation and reduction potential, oxygen level, pH, temperature, as I said earlier, and the other very different parameters like total nitrogen. And oxygenation is a very, very important parameter because we have to think about it. The one side is energy requirements. The main energy requirement of these systems related to oxygenation. And the other parameter is how much oxygen concentration do we need in our systems for the different species in the RAS systems. And mechanical filters, we can use biofilters also, and ozone chamber even for the disinfection, and carbon dioxide degassing, because if we don't degas the carbon dioxide, we affect the growth of the fisheries. And we need different type of pumps to recycle the systems, not only for water, but also the sludge. And this is the zero waste concept we are going to discuss in our project in the next months to get enough sludge, and we want to evaluate how do we use the sludge as a fertilizer in a plant growth or as a protein source or main feed source. And another one, we can use different environmental technologies like the physical treatment, the plate separator, denitrification systems because of the contaminants and other impurities in the recycled water. And phosphorus removal, very important, because when they discharge as a sludge at the bottom of the pools, we have to collect the sludge, and after the collection of the sludge, we have some impurities in the, how can I say, as a suspended solids or dissolved impurities in the recycled water, and we have to treat this phosphorus and nitrogen. And at the end of the process, we have to dewater the sludge using bell filter or decanters, and 10 or 30% of dry matter, and reject what we have. Fish tanks, different materials, polypropylene, polyethylene, fiberglass, or metal, we can use based on our species and based on the investment cost. And feeding systems, very important, because if we talk about the investment cost, we have to choose the correct one for the feeding systems. We have so many different alternatives to get to get enough water treatment, and mechanical, gravitational, and chemical and biological treatment system we can use. By the way, we can use also the hybrid systems, including not just for mechanical, gravitational, also the chemical and biological. Sorry. Here is a mechanical filtration used in the RAS systems, especially for drum filters, generally preferred because of the basic operation. And we can use the different growth media, we call the biomedia, in plastic materials. And we can, especially, we can use these materials for the nitrification, denitrification process as a biofilter, as a fluidized bath filters, and different types of oxygenation equipment. If we need just low head oxygen, the oxygen platforms is okay for us. By the way, if we need more oxygen for the different species, generally the cone systems used for the high capacities. Also, we can use ultrasonification, UV systems, and different types of disinfection units to get enough disinfected water to recycle. And also, as I said, the pumps, the spec Scorpion pumps, Enterprise pumps, and MDM advanced pumps we need. After the oxygenation, the second energy requirements based on the motor and pumps. Monitoring is very important because in the near future we are going to evaluate unmanned operating systems like dark factories. Maybe we can think about the dark factories as a dark aquaponic systems using artificial intelligence systems, and we have to monitor many different parameters. Nowadays, we can evaluate the monitored parameters, oxygen, pH, temperature, salinity, oxidation reduction potential, and flow rate also. Okay, we have some advantages and we have disadvantages with the RAS systems. I have mentioned about the advantages. By the way, we have disadvantages because of the upfront investment. We need more investment than the conventional systems in the RAS systems because of the monitoring systems, sensors, extra pure water requirements, or enough parameters to reduce, and pumps, and we need a roof in a dark or in a closed systems. And also we need high cost for the operation than the conventional systems. And we have to compare based on the production capacity and investment and operational cost. And it's a really big and huge amount of dollars of euros we need. And some of the financial institutions support this kind of things as financially in the sustainable development projects. Okay, there are some examples in Japan. You can see really big one. Okay, the concept of sustainability, Professor Güray will mention about the sustainability. Basically, by the way, I'm going to talk about in a different way. We need sustainable development, and we have to take into account the environmental, economic, and social parts of the systems. And in the aquaponic, in aquaculture, in every kind of project, we have to think three different parts of the or side of the project. We have the economic part or side of the project, environmental side, and social side, and we have to explain to get sustainable systems. Okay, these are the theory. Professor Güray will mention these systems. And why do we need for the RAS systems or aquaponic systems in the sustainability? For the first goal is no poverty. We have to think about, or we need to think, the aquaponic systems may be basic systems, but operated in the villages, in the small communities, even in really low cost investment. Maybe we can follow or monitor less parameters. By the way, if we build enough capacity, like the Herman is doing this kind of things in the pilot systems, very important studies. Thank you, Herman. And this kind of, if we implement this kind of systems in the villages, we can think about this no poverty. We can demand some requirements of the community. And the second one is zero hunger. It's related with the one. And the third one is good health and well-being. If we produce more protein, and if we in the pilot systems or the basic systems, we can get more protein, more food, and we can achieve good health and well-being in the communities. Sustainable food systems, okay, especially FAO interested in the food system wheel. These are really recent publication, and FAO interested in the food systems, especially for sustainable fisheries. 5 core principles of sustainable aquaculture. One is environmental responsibility. Use eco-friendly systems, non-fat, recirculating integrated, reduce water land use, waste and chemical input, and protect aquatic ecosystems. The second one is in the principle, as a principle, economic viability, ensure long-term profitability and competitiveness through cost-effective methods and sustainability sourced inputs. And the third one is social responsibility, support fair labor practices, and the fourth one is animal welfare. This is very important, and biodiversity. We can mention about the animal welfare and biodiversity in the specific areas, in the specific countries, to get different type of biological species. And the last one is governance and policy frameworks require strong legal structures to get sustainable aquaculture. And importance of sustainability in aquaculture, conservation of natural resources, food security and supply, reduction of environmental impacts, economic sustainability, social responsibility, and innovation and technological development. These are the environmental indicators: use of space, dependence of water, use of energy, proportion of water, renewable energy, use of nitrogen, phosphorus, potential of global warming, etc. The economic indicators: ratio between net income and initial investment, a net present value, payback period, and the social indicators, very important part of the aquaculture systems, especially for RAS systems, development of local economy. We mention about in the sustainable development, local economy. If we want to go in the sustainability road, we have to think about the local economy, supporting of the local economies. For this reason, RAS systems or aquaculture system, aquaponic systems should be discussed and developed. And the other one is use of local workers, investment to create direct employment, safety at workplace, pay equality, and gender inclusion. Okay, if we think about as a biomimicry, we can think this kind of flow sheet for the RAS systems. This is the next generation approach, like in the nature. Aquaculture tanks we need, organic waste to energy in the aquaponic integration, algae reactors. I especially would like to talk about the algae reactors. In the next generation RAS systems, the algae reactors is the part of the aquaponics, because algae always think about the future next generation food resource. The other one, solar power from effluent for the disinfection units especially, and different kind of disinfection unit is a part of the next generation RAS systems. Okay, eco design. I'm going to say something about the eco design of sustainable product regulation and RAS relation. Expanded scope under ESPR directive, and durability, repairability, and upgradability. digital product passport integration for the next generation RAS systems, resource and energy efficiency with environmental performance labeling we need for the any kind of materials, even our fishery materials. Sustainable and non-toxic materials we need to build and operate of the RAS systems, and also waste as resource principle. If we think about the circular economy, we have to think that all kind of waste generated from the aquaponic systems or aquaculture systems as a source, as a fertilizer, as a protein source, as a feed source, and we have to think about the real capacity of the total sludge. And the valorization of secondary outputs, cross-sectional industrial symbiosis we need. As you can see, the different industries, some of the residues or waste is an important protein source for our aquaponic or aquaculture systems. We have to think about different type of waste systems in the future, and multi-purpose system design we need, like algae production and aquaponic between and linked systems. Some of the treatment systems like ecosystem inspired design should be taken into account because of the treatment cost. Okay, and maybe we can think about the preliminary treatment of the wastewater coming from the aquaculture systems in the more basic or low cost investment ecosystem inspired design treatments because of the operational and investment cost. Also, nature-based filtration mechanisms is very important, and some of the research person interested in this kind of materials or systems. Another one is the bio-inspired energy optimization. If we compare the bio-inspired energy optimization and solar energy and heat transfer, we have to think about decrease the operational cost in the RAS systems. And microbial communities is very important. Maybe in the near future, we are going to transform some sludge to a really good protein sources using the new microbial communities. And okay, I haven't enough time, I think so. I'm almost half of the presentation.
No,
Okay.
please continue. We wait.
Okay.
Yeah.
I'm going to finish within 10 minutes. Okay, I have mentioned a subject in Turkey in this presentation. In the nature, in the conventional system in aquaculture in Turkey, a aquaculture farmer mentioned about these systems. Algae on the surface protect fish from UV radiation. Mosquito larvae feed on algal detritus, and algal detritus fish consume mosquito larvae, and algae also increase in these systems. It's a natural recycling systems, and we need to think about this kind of biomimicry approaches. Your trash is by cash study, like in the nature. And as you know, there is no waste in the nature. In these systems, we have to think about the algal detritus and mosquito larvae as a feed for the fisheries. Okay, we have so many guidelines and standards for the sustainability in aquaculture systems. This is the real recent publication, FAO guidelines for sustainable aquaculture. Okay. In the environmental evaluation, carbon footprint and environmental footprint, we have to think about it. Greenhouse gas emission, water use, waste generation, land use, resource depletion, and pollution. We have to think. And water consumption, there are some numbers with the water consumption between the different species, different energy consumptions in the different systems for the different species, growth of the different species, the feed conversion ratios for the rainbow trout to tilapia and gilt-head sea bream, as you can see. And energy optimization and renewable energy are discussed in the recent articles. Water quality parameters are very important. Okay. Wastewater composition based on the different capacities and the different species like shrimp and fisheries. And different type of desertification units. Okay. Energy consumption. Okay, this is the heat pumps and chillers. If you want to use to reduce energy consumption. Sustainable hybrid systems should be taken into account. And you can see the recent articles about the aquaculture and especially RAS systems. Carbon footprint of shrimp cultured in RAS. Carbon footprint again. Sustainable feed sources and ingredients. We have to think about different species as a feed source. There are so many different environmental effects. Water management, eco-friendly farming, and environmental biosecurity should be taught. Another one is economic and social dimensions. Investment cost, very important. Operating costs, very important. These are the recent articles about the economical sustainability. Okay. So many different standardization for the food, hygiene, and aquaculture stewardship council standards we have. Employment for the social part, social side of the sustainability, very important. Just 54% of captured fisheries and 36% in the aquaculture systems. 34 million people in all over the world. And some deployment impacts. Okay. Okay, there are so many different recent articles. I'm going to continue. Different plant. Okay. These are the automation systems. Okay. Just a moment, please. Okay. This is the Kingfish company in Netherlands and USA as a land-based RAS facility. Okay. And we have some questions with the RAS support systems. Some recommendations may be invest in local R&D and training, design systems based on species and climate needs in your country, promote renewable energy and circular economy integration, strengthen social engagement and policy support. If we think this kind of investment as a aquaponic or RAS systems, we have to take into account these approaches in our projects. Okay, there are so many different approaches in Gaza, Palestine. You know, the right to adequate food is recognized as a fundamental human right in Article 11 of the United Nations Environmental Covenant on Economic, Social, and Cultural Rights. By the way, we have different pictures from the different parts of the world. And at the bottom line, we have a very important poet, Nazım Hikmet, and he says, "Kardeşlerim bakmayın sarı saçlı olduğuma." I have translated in Spanish and Norwegian, and we have to think human being need enough food, and we have to use aquaculture as a bottom line. Okay, that's it. Thank you very much.
Thank you very much, Dr. Kamil, for your talking. I'm very impressed. I'm very impressed for that. So I would like to leave open for our audience that's been increasing a little bit. If they have
Okay.
any question that you would like to ask to Dr. Camille, if for any reason any of the Spanish speakers present here cannot speak any English, please do your question in Spanish and I can translate for him.
Hi, good morning for me. Greetings. My question is about